Hello viewers, welcome to Anushree Tutorials. In this video we will learn about rational numbers. See, before going to about rational numbers, once recap what we have learned in our previous classes. We learned that various types of numbers in our previous classes. For example, we learned about natural numbers. Natural numbers are nothing but all counting numbers we are calling as natural numbers, and then whole numbers. Counting numbers including zero are called whole numbers, and then integers. All counting numbers with a positive and a negative sign along with zero are called integers. And we may get some doubt, apart from these is there any numbers? Yes, apart from these there are different types of numbers. Suppose for example if you take 1 by 2 which does not comes under these categories. So like that the natural numbers, whole numbers, integers are there. Like that there is another type of category that is nothing but rational numbers. If we observe the rational numbers, the numbers which are in the form p by q, where p and q are integers and q must not equals to 0 are called rational numbers. That is nothing but, you learned already about fractions. Fractions comes under rational numbers. Along with the fractions, we have negative fractions also in rational numbers. Once if we observe our number system, we have natural numbers, that is all counting numbers are natural numbers. Counting numbers along with zero are called whole numbers, and whole numbers with negative numbers are called integers. All these numbers including negative and positive fractions are called rational numbers. So the numbers are categorized as natural numbers, whole numbers, integers and rational numbers. From this picture we can conclude three statements, that is all natural numbers are rational numbers but all rational numbers are not natural numbers. Like that all whole numbers are rational numbers but all rational numbers are not whole numbers. And all integers are rational numbers but all rational numbers are not integers. So remember about rational numbers. Now see how to represent these rational numbers on number line. So to represent rational numbers in number line, we have two cases. That is, if the numerator is smaller than the denominator, if the numerator is bigger than the denominator. These two cases we have. Observe the first one. If the numerator is smaller than the denominator, always it must lies between 0 and 1 only. So we need to take 0 and 1 only in the number line, and then observe the denominator. Here we have denominator as 7. So subdivide this 0 and 1 into 7 parts and mark each part as 1 by 7. So the first part is 0 by 7 and the second is 1 by 7, 2 by 7, 3 by 7, like that. 7 by 7 is nothing but 1. So from this we need 4 by 7. See, if you observe here we have 4 by 7. So like this we can represent rational numbers on number line. Now see the second case. If the numerator is greater than the denominator. So if the numerator is greater than the denominator, we need to convert that rational number into mixed fraction. So after converting the rational number into mixed fraction, observe here what is the whole part. 3 is the whole part in this mixed fraction. So this number comes between 3 and the next whole number 4. So in the number line we need to take 3 and 4. And in between 3 and 4, here the denominator is 5. So we need to make 5 subdivisions. So each subdivision represents 1 by 5 part. So 3 then after next subdivision is 3, 1 by 5, 3, 2 by 5. So that like we will represent rational numbers on the number line in these two situations. Now see one example. Suppose if we have minus 2 by 3. See how to represent minus 2 by 3 on number line. Here the numerator is smaller than the denominator. So we think that if the numerator is smaller than the denominator, the rational number lies between 0 and 1. But here it is a negative number. So if the rational number is a negative number, it lies between minus 1 and 0. If it is a positive number, it lies between 0 and 1. If it is a negative number, it lies between minus 1 and 0. So in between minus 1 and 0, we need to make 3 subdivisions because the denominator is 3. So make the 3 subdivisions and each subdivision mark as minus 1 by 3. So the second part we will get it as minus 2 by 3. So like this we can represent the negative rational numbers on the number line. So now see one more number line. See here, if you observe the natural numbers number line, is there any number between 3 and 4? No, in natural numbers or whole numbers, there is no number between 3 and 4. So if you observe the negative numbers means integers, is there any number between minus 2 and 4? Yes, in between minus 2 and 4 we have minus 1, 0, 1, 2 and 3. So like that, is there any number between any two rational numbers? Yes, we can see that in our number line. See, between any two integers we have number of rational numbers. Infinite number of rational numbers are there between any two integers. If you take 0 and 1, if you divide that into 10 subdivisions, we can mark 10 rational numbers on the number line. If you subdivide these 0 and 1 into 100 parts, you can mark 100 rational numbers. So there are infinite number of rational numbers between any two integers on the number line. See one example how to represent numbers on number line. See, can you find rational numbers between 2 by 5 and 3 by 5? So in between 2 by 5 and 3 by 5, what are the rational numbers we have that we need to find? So to find that, we need to convert this 3 by 5 and 2 by 5 into their equivalent fractions. So 2 by 5 I am converting as 20 by 5 and 3 by 5 I am writing as 30 by 5. Their equivalent fractions, their equivalent rational numbers I am taking. So now mark 20 by 50 and 30 by 50 on the number line, which is nothing but 2 by 5. 2 by 5 is equal to 20 by 50 and 3 by 5. In between these two numbers we can mark 21 to 29 rational numbers. 21 by 50, 22 by 50, each subdivision marks as one rational number. So like this we can write the rational numbers between any two rational numbers. If you observe this picture clearly, we can understand how there are infinite number of rational numbers between any two integers on the number line. Now see in the first picture, observe this number line. What is there? We have number line, and on the number line we are observing between 0 and 1 only. Initially there is no number between 0 and 1. If you consider this as integers number line, there is no integer between 0 and 1. If we closely observe, there are rational numbers between 0 and 1. See, if we subdivide it into 5 divisions, we may get 0 by 5, 1 by 5, 2 by 5, 3 by 5, 4 by 5 and finally 5 by 5. So each part is a rational number. If you closely observe between 2 by 5 and 3 by 5, in the previous slide we discussed that 2 by 5 and 3 by 5 between also there are number of rational numbers. Again, if you closely observe 22 by 50 and 23 by 50, by converting this also into its equivalent fraction, we can write again between rational numbers. So like this, if you observe clearly, there are number of rational numbers are there between any two rational numbers. Now see how to write equivalent rational numbers. So how we write equivalent fractions? In the same process we write equivalent rational numbers also. See, for example, here I have minus 2 by 7. I am going to write an equivalent fraction for minus 2 by 7 with the denominator as 63. Now here the denominator is 7. 7 needs to become 63. When the 7 becomes 63, 7 9 63. So numerator also we need to multiply with the same number, that is 9. 2 9s we need to take. So it is 18. The same symbol only we will get for equivalent rational numbers. We use it to do addition and subtraction of unlike rational numbers. So now see how to add rational numbers. See, simply we are adding the numerator of the rational numbers given if the denominators are same. Keep the point in mind. If the denominators are same, then only we will do addition of numerators. So here 13 by 6 and 11 by 6. In both the rational numbers, denominator is 6, same. So simply I am adding 13 and 11, so I get 24 and give the same denominator for the answer also. Okay. So now see the second case. What if the denominators are different? See, if you observe 3 by 4 plus 4 by 5, here the denominators are different, 4 and 5. So in this case, we need to take the LCM of 4 and 5. So the LCM of 4 and 5 is 20. So I need to write equivalent fraction of 3 by 4 with the denominator 20. So 4, when 4 becomes 20, 4 5s. So 3 5s 15 I need to take. Like that 4 by 5 and 5 becomes 20, 5 4s. So 4 4s I need to take. So like this 3 by 4 and 4 by 5 are converted into their equivalent fractions. Now see the denominators are same. So simply we can add the numerators. Like this we can perform. So see one example for how to do subtraction. See in the subtraction also, if the numerator is denominator are same, simply we can subtract the numerators and we will write the same denominator for answer also. Now see what if the denominators are different. Same thing what we perform in the addition, we need to take the LCM of the denominators and we need to write the equivalent fraction of these 9 by 2 and 10 by 3, so that we can perform the subtraction of rational numbers. See, to do multiplication of rational number, when you are multiplying a rational number with an integer, simply multiply this integer with the numerator. So numerator and integer we need to multiply and give the same denominator. When you multiply a rational number with another rational number, here you need to multiply the numerator with numerator and the denominator with denominator. So like this we can perform the multiplication operation on the rational number. Now see how to do the division of rational number. While doing the divisions of rational number, we need to take the reciprocal. So what is reciprocal? Numerator becomes denominator and the denominator becomes numerator. So while doing division in rational numbers, instead of doing division, we do multiplication by taking the reciprocal of the second fraction. So in the previous one slide we discussed how to do the multiplication. So like this we will perform basic arithmetic operations on the rational numbers. Hope you understand this concept. Thank you.